Example 4 says graph y equals 4 over x squared plus 2. State the domain and range. So we always start our graphs with the vertical asymptote. So we're going to start with x squared plus 2 equals 0. Yesterday we did this in the examples. You did it in the homework. It was one of the homework problems. It was one of your graphs. And we're going over it a third time today in class, and you'll see it in tonight's homework. When you see x squared plus a number, you should recognize there's no solution to that. You shouldn't be going off and doing things. One of the things I absolutely love about Algebra 2 is that it allows you to really think, not just motor along. Is you've got to stop and think here. So there's no solution to this, so there's no vertical asymptote. To determine a horizontal asymptote, you do the degree of the numerator. There's no variable, so the degree is 0. The degree of the denominator is 2. You guys, I gave you a chart, and you needed to have been looking at it every time we did them in class yesterday and every time you did a problem in your homework. And we're going to keep looking at it. If you look at it 20 times, you're going to get it stuck in your brain. When the degree of the numerator is smaller than the degree of the denominator, what's the horizontal asymptote? Y equals 0. Don't write down 0. I'm going to mark it wrong tomorrow, on Friday on the quiz. It's not 0. 0 is a number. Y equals 0 is a horizontal line. There cannot be a slant asymptote and a horizontal asymptote at the same time, right? That it wouldn't make any sense. So there's no slant asymptote. Then we're ready for a table. Since there was no vertical asymptote, that means any number is okay. So let's just use -3 to 3. And this one I can do without a calculator. I'll tell you the problems when you use your calculator and when you don't. If they're simple like this, we want to go without the calculator. If I plug in 0, I get 4 over 2 is 2. Now, this is another reason why I love Algebra 2. I get to really think here. Because there's an x squared and there's no x, you understand there's no x to the first anywhere else. So I get to really think. All the positive values will give me the same output as the negative values because I squared it. Score! I only have to do half the values in my table. I love that. All right, so 1 squared is 1 plus 2. That's 4/3, which is 1 1/3. And then I'm going to go plug in the same number for -1. Yay! If I plug in 2, 2 squared is 4 plus 2. That's 4/6, which is 2/3. And then if I do a 3, 3 squared is 9 plus 2 is 11. All right, nobody's expecting you to have a calculator brain, but 4/11 I can tell is a little bit less than a half, right? So no need for the calculator, but 4/11 I can say it's a little less than a half. So let's start with our grid. So I need my y-axis in the middle, and I look at the values. I don't have any negative y values, so I can lower my x-axis. All right, I have no vertical asymptote, but I do have a horizontal. Please make sure you are darkening your asymptotes. I did write some of you notes that they're either too light or I couldn't see them at all. Now, it could be that my eyes are old. I can't see so well. So make sure you darken them. They don't need to be light. They definitely need to be visible. Okay, so let's plot our points. I have 0, 2. I have 1, 1 1/3. Then let's use the symmetry and put the other side. I have 2, 2/3, 3, and just a little bit less than a half. Make sure when you draw this, you make sure it's not touching the horizontal asymptote. So my domain is all real numbers. Vertical asymptote and domain are connected. Horizontal asymptote and range are not directly connected. They're indirectly. Does anybody want to attempt the range? Jaslyn, you want to try it?
So y is greater than 0?
No, because if y is greater than 0, it would go up forever. Do you see there's a boundary?
Oh yeah,
Everything
y
but 0.
is okay, y is greater than 0 but less than 2.
Okay, so we're going to write it like this because it actually touches 2,
Oh yeah.
right? Okay. So we're going to write that. It's not two separate pieces, so we're going to write this as a double inequality. 0 is less than y is less than or equal to 2. Now let's do our intercepts. I have a y-intercept of 0, 2, and it never touches the x-axis. Do me a favor on your homework and on the quizzes and the test. Make sure you're boxing the stuff that you're finding because you're going to have so much work and it's going to be a little treasure hunt for me to try to find your stuff. So it makes it easier if you'll box it. Also, I'm seeing homework where I'm getting no table. Like, okay, you've got to write down the table so I can verify the points. All right, so I think we have everything. Any questions on this one? So the ones that are a constant over x squared plus a number, they look like a volcano. Do you notice it's not shooting up to infinity? Okay?
It's kind of like a parabola.
Yeah, sort of. Not exactly.
I was saying kind of.
Yeah, sort of. I just think of it as a little bit of a volcano, how steep or small it is. All right, let's look at example 5. We're going to do another one like this. It says we want to graph y equals 3x squared over x squared minus 1. So we're going to start with the vertical asymptote. Now this one's different from the previous example because it's x squared minus a number. Those have a solution to them. X squared plus a number does not. This one's a difference of two perfect squares, so I will factor it. So bummer, I have two vertical asymptotes. The degree of the numerator is 2. The degree of the denominator is 2. So Andrew, what would be my horizontal asymptote on this one if the degrees are equal?
Y equals 3.
Good job. Y equals 3. When the degrees are equal, it's just the coefficients, 3 over 1. Awesome. Again, there can't be a slant asymptote when you have a horizontal asymptote. We're ready to make a table. If you're struggling with the table for two vertical asymptotes, let me try to help you out here. If you draw or imagine the x-axis, I need 3 points to the right of 1. Now, I have never said they had to be whole numbers or integers. Okay, I haven't said that. I said 3 numbers. So I have -2, -3, -4. There are not 3 integers in between -1 and 1, but there are certainly 3 numbers. There's infinitely many in between there. So we definitely want 0, but what would be 2 other nice, decent numbers to try? 1/2 and -1/2. So let's do 0.5, 0, -0.5. All right, once I see the decimals, I'm going to use my calculator. So let's do this together. Take out your graphing calculators, and we're going to go to our Y screen. And I want you to pay close attention to this, because I would hate for somebody to, get the graph wrong, and all it was is that you entered it in the graphing calculator incorrectly. If you have more than one term in the numerator or denominator, you have to put a parenthesis around it. So it's 3x squared divided by parenthesis x squared minus 1. And you do second graph, and there's your table. Now, this will give you every single number except the 0.5 and the -0.5. So I'll give you a moment to try to get all those down. And then let me go over, even though I've done this before, I'll go over it again, how you can get the decimals. I'm going to show you 2 ways, actually. Okay, let me show you how you can get the 1/2 and the -1/2. If you press graph, okay, this is neat because I can get an idea of what the graph looks like. But watch what you can do, okay? Does everybody press graph? Then you do trace, and you just type in 0.5, enter, and it spits out the y value. So instead of ever going to your table, you could do all of them on here, but it would be a lot more time consuming. And I can do -0.5 because my trace is up. Okay, that's one way to do it, is on the graph itself, press trace and type in what you want. Here's a second way. If you press second window, again, if you press second window, you can go down to the independent variable and put it on ask. Now what happens if you press second graph, there's a blank table. So on a problem that if you had a bunch of fractions or decimals, you would rather, that would be faster than, trying to type them each in, I think, on the graph, doing trace. I don't know, your choice.
But it'll also be up there once you finish too, if you want to go back and look.
Right, yeah. Okay, now let's go back and turn that off, because I don't want you to be frustrated and be like, how do we do that? Where do we go? So go back to second window, that's table set, and put it back on auto. Alright, so let me quickly fill in my table, and then let's graph. So let's start with our grid. And do our asymptotes. Love playing with the colors. I've got x equals -1, x equals +1, y equals 3. Yay, that's so nice. Do make sure that you're making a scale somewhere that lets me know how many tick marks you have. Alright, then here we go. I have 2, 4, 3, 3.75, so you can tell. And I have the symmetry over here. And then I had 0, 0, 1/2, -1. So it almost looks like a parabola in the middle. Make sure when you're drawing the different pieces that you make them hug the asymptotes, but don't make them touch the asymptotes, okay? That's important. Let's talk domain. Remember, domain is directly tied to the vertical asymptotes. So the domain is all real numbers except plus or minus 1. Now the range is pretty interesting on this one. Anybody want to try it? You see they're different pieces now, so it's different from example 3. Hannah, you want to try it?
Not really.
Not really? Okay, that's alright. Megan, you want to try it? Can you do part of it? Any part of it?
Would it be y is less than 0?
Okay. But it equals 0 too, right? So it's y less than or equal to 0. Or, now let's do this piece. How would you say this piece? You're doing it. What would you say?
Greater than 3?
Yes. Y greater than 3. There we go. Look, you did it. Okay, y does touch 0 on this piece, so it's y less than or equal to 0. But then here it doesn't touch anywhere when I look, so it's y greater than 3. All right, let's talk intercepts. The x and the y intercept are the same. It's at 0, 0. And it's not going to cross or come back anywhere else. So let's double check. I've got my asymptotes, domain and range, and my intercepts. Okay? All right. Let's try the last one. Alright, it says graph y equals x squared minus 2x minus 3 over x minus 4. So we always start with the vertical asymptote. You set x minus 4 equal to 0. So the vertical asymptote is x equals 4. When we get 1, it's like happy dance. We only have 1, yay! Alright, who would have thought? Alright, the degree of the numerator is 2. The degree of the denominator is 1. Alright, McKenna, what's the horizontal asymptote?
Oh, we have to do long division for the, not the horizontal, the slanted asymptote.
Right, so there's no horizontal asymptote, so make sure you write that, guys. Because if you don't, that's going to tell me you didn't know. So you're absolutely right. You do long division for the slant asymptote. Now what I'm going to do is I want to try to refresh your memory from, this is back in chapter 5. Do you remember if you divide by x minus a number, you can actually do it faster with synthetic? Yesterday I didn't want to do that because if you're dividing by 2x plus 1 or x squared plus 3x minus 9, you've got to do long division. So I wanted to do that, but in this case, I can do synthetic. So let's just review that because it's way faster. So I bring down the 1, 4 times 1 is 4, add the column, 4 times 2 is 8, add the column. Remember to figure out your answer, x squared divided by x to the first is going to give me an x. So the slant asymptote is x plus 2, and we don't care about the remainder. Alright, I'm going to make an xy table. 5, 6, 7, 3, 2, 1. Let's use our calculator on this one. Now be careful, you have to enter the numerator in a parenthesis and the denominator in a parenthesis. So I'll give you a head start on me.
Can we write down the decimal points?
Absolutely. Yeah, I had decimals on here. So remember there's a vertical asymptote at x is 4. And then, you guys, we should not be having any trouble graphing a slant asymptote that it's this simple, y equals x plus 2. You go up to 2, use the slope. 1 over 1, 1 over 1, 1 over 1, okay? That is some Algebra 1. Alright, then I'm going to plot my points. Now remember, and I am writing you notes on your homework. I hope you're looking through it to see if I wrote anything. You need to make sure you're drawing the curves in such a way that they're hugging the asymptotes, but they make that general shape. You don't want to stop anywhere that you're not supposed to. These are nice, smooth curves. then your domain is tied to the vertical asymptote. It's all real numbers except x cannot be 4. Now the range, this is a tricky one, and we did one yesterday in our notes, so we're doing this a second time today. You're actually on your graph, and you guys, you are smarter than your calculator. You press window, and you need to go up to about maybe 14 or 15, otherwise you're not going to see half of this graph, even though we know there's another half to it. So remember that just because you press graph doesn't mean the calculator did everything you wanted. Okay, you're smarter than your calculator. So I'm going to have to take my y max and make it go up higher. And then when I do, I'm going to do, once I press graph and I see this, I do second trace minimum. This is a minimum. And once you find that, you know it's that value and everything above it. So I got y greater than or equal to 10.47, because it does touch that value, or y less than or equal to 1.53. So make sure you're able to get both of those numbers on your calculator. Now, I have an x-intercept of 3, 0, but it hits again, doesn't it? So, let me go pop mine in real quickly. Excuse me. Alright, I'm going to go to y max and put it up to maybe, pardon me, 15.
It spreads.
So I see it's crossing here. So let's do second trace, and that's a 0. And you just have to get left bound, right bound. So I'm getting -1, that's nice. Now I could have gotten it a second way without a calculator. You understand x-intercepts are found by setting the numerator equal to 0. We put that, it's in our notes, it was the very first thing. The y-intercept is found by letting x be 0. Well, then that's -3 over -4, which is 3/4. And you can tell that looks about right. Not too shabby. Alright, so this was our second day, and we just repeated. Example 1, 2, 3, 4, 5, 6 were the exact same types again.